I'm going to do a few extra problems for the test 4 review. We're going to call it Physics Bootcamp Test 4 Extras. Problem 1. What is the velocity of sound in seawater? How long will it take to hear a submarine that is 120 miles away in the ocean? So we're going to have to rely on the equation for the velocity of sound in a liquid. And that equation is the square root of the Book's modulus of the liquid divided by the density of the liquid. It turns out that the velocity of sound in liquid or even in solid depends on the elastic properties of the, so this is the elastic property of the medium, elastic property divided by the inertial property. So known as the bulk modulus, okay? And the bulk modulus tells you how hard it is to compress that. Bigger the bulk modulus, the harder it is to compress that liquid, the compressibility of the liquid, or you can think of it almost like the inelasticity. So if a liquid has a big bulk modulus, it's very hard to compress it, and therefore it's not an elastic medium. Okay, it's not a very elastic. If it's very elastic, that means the bulk modulus will be low. So we can almost think of it as the, we could call this the inelasticity. Because inelasticity, okay, divided by density. Okay. So the more the bulk modulus, the more inelastic the medium is. The inelasticity of the medium divided by the density of the medium. Okay? The less the density, the faster the speed of the sound in that medium. Why? Well, you can kind of make sense out of this. If you have some kind of liquid, right, and you make a certain sound over here and you want that sound to propagate, you want that medium to be very, very inelastic. So a propagation over here quickly results in a propagation to the other side. So that propagation is sent very, very quickly. So vibration of sound, vibration of the molecules, and then the compression, rarefaction, compression, rarefaction. So that vibration is sent over very, very quickly to the other side. So if it's very inelastic, that propagation will travel faster. How about the density? What is that going to affect? Well, the less dense the liquid is, that means there aren't too many liquid molecules in the way, to get in the way of that propagation, right? The more dense it is, that means there is a bunch of molecules over there that are going to get in the way. So in order to send a propagation of sound wave, you're going to have to vibrate all of those liquid molecules in order to cause the vibration to get across, the propagation to get across. What we have to do is use the bulk modulus of water. The bulk modulus of water turns out to be 2.1 gigapascals. Okay? And giga means 10 to the 9th. And the density of water, density of seawater, we're going to have to use the density of seawater, which is going to be 1030 kilogram per meter cubed. So we're going to have to use the density in units of kilogram per cubic meter. So let's calculate what is the velocity of the sound in seawater. Square root of 2.1, giga is 10 to the 9th. And then in the meantime, I'll also calculate the units. Pascals is Newton per meter squared. And then you have 1030 kilogram per cubic meter. So if I calculate that, 2.1 times 10 to the power 9 divided by 1030. Now I have to square root that. And you get velocity of sound is equal to 1,427.88 meters per second. So that's actually a lot faster than the velocity of sound in air, which is roughly about 345 meters per second. This is 1,400 meters per second. Now, what's the units of this? Well, Newton per meter. Newton is a kilogram meter per second squared divided by meter squared. Now I multiply this by what? Meter cubed over kilogram. Meter cubed over kilogram. Because you're dividing this, it's the equivalent of multiplying by the reciprocal, right? So then you have meter squared cancel a meter, kilogram cancel a kilogram. What do you end up having? Meter times meter, meter squared over second squared. Then you take the square root of that. Meter squared over second squared square root. You get what? Meter per second. So the units works out to give you units of velocity. Okay? Now, how long will it take you to hear a submarine? So let's say you happen to be inside of a submarine and then there's another enemy submarine 120 miles away, and then all of a sudden it makes a certain noise. How long will it take that noise to travel to you? So then you say time is equal to distance divided by velocity. Distance is 120 miles, right? Each mile is 1.6 kilometers. So 1.6, that will give you in units of kilometers. Each kilometer is 1,000 meters. So multiply by 1,000. So you got to convert from mile to kilometer by multiplying by 1.6, then 1,000, and this gives you units of meters. You divide this by 1,427.88 meters per second. Meter cancel, and you get units of seconds. So time is equal to 120 times 1.6 times 1,000 divided by the answer that we got when we did this calculation. And then we get 134.465 seconds, okay, which is about 2 minutes or something, right? So after it makes a certain noise, it will take you a little more than 2 minutes to hear that, and of course by that time the submarine is a little bit closer to you, and now you have to react to do something, whether or not to send a torpedo or fire at them or whatever. Okay, thank you very much.